Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic.
Hello everyone, welcome back, and with this lecture we are going to cover the second machine learning algorithm within this playlist, which is logistic regression. So I hope you are also as excited as I am. So without any further delay, let's get started. Let's start by understanding the use cases of a typical linear regression problem and a logistic regression problem. So a linear regression problem is mostly used for problems like where you're trying to predict the price of a house, or let's say you're trying to predict the price of a stock given few features, or let's say marks obtained by a student depending on, let's say, how many hours he is studying per week or how many hours he is watching TV. These can be helpful in order to predict the target variable. On the other hand, the logistic regression problem is used in order to make a decision or choose a class between multiple classes. Let's say you're trying to predict if a given email is spam or ham, if a candidate will pass or fail, or the answer is simply yes or no, something like that. And this is exactly what we are going to cover today, that how a machine learning algorithm helps us to classify between these classes in order to make a correct decision. The picture or diagram that you can see on the left hand side is an example of a typical regression problem that I believe we are already familiar so far in this playlist. This could be the example of one of the regression problems where you're trying to predict the price of a house or a car with a given feature. Let's say how old the car is if you're buying it secondhand, or let's say how many bedrooms you have in the house if you're trying to predict the price of the house. But on the other hand, if you are trying to solve a classification problem, the data will definitely look different compared to the previous one. Over here, you will have only two classes like class 0 and class 1, and you will have nothing in the between. And you need to choose a machine learning model that can work in such a way that it will be able to make a decision, or let's say classify between one of these classes. Let's move ahead to understand that how do we actually do that, or rather I should say that how the logistic regression model does that. So when we are using a logistic regression algorithm, in order to classify between two given classes, let's say 0 and 1 we have here, the model will again try to draw the straight line the way it does with a linear regression problem. However, you can understand that this straight line is definitely not that helpful in order to understand that which class we should go for. And this is exactly where the sigmoid function comes into the picture. Just to make it super simple for you, all this function is doing, it takes the straight line drawn by the machine learning model and then it squeezes it like this. It squeezes in such a shape where we can consider a given point as the threshold, and depending upon this threshold value, let's say we consider this to be 0.5. If you get an output of, let's say, 0.6, you will classify that as the class 1, or if you get an output of, let's say, 0.4, then you will classify that as class 0. Again, I'm repeating, this sigmoid function does nothing but squeezes this straight line in such a way that it will now help us in order to classify between two given classes. And as we have previously studied or understood, going by the equation of a straight line, which looks something like this, where beta 0 is the origin point for the straight line, and beta 1 will be the weight given to our feature, or you can say it will be the value of the slope. But as we have discussed so far, that we are now using the sigmoid function which is squeezing the straight line into this particular shape. So now the equation as well is going to be changed, and this is the equation of a sigmoid function which says your predicted value will be 1 by 1 plus e to the power minus x. Now what is this e value? This e is a constant number which is also called called Euler's number, and its value is very close to 2.71. Please keep it as simple as that. Just consider this as a constant value. There is no rocket science or quantum physics needed in order to resolve this value, that how did we get this, what is the meaning of this value. Just consider this value as a constant value. And now let's talk about this exponential term, which is minus x. Pay attention to the left hand side. Of course, we are trying to draw a straight line using this equation right here, which is b0 plus b1 x1 in terms of one feature, and this entire equation will definitely give us some value for y hat. We take this value of y hat and place it over here at the place of x, or the exponential term on the top of the Euler's number, and then it gives us the final value for this term. That will give us the final value for this entire denominator term, and then this entire whole term will be calculated accordingly. To elaborate this further, that how the value of x changes this entire term, let's see some explanation. Okay, please pay attention here. It says when the value of x will be equals to infinity, in that case e to the power minus infinity will become 0, and this entire term will become 1, because 1 plus 0 at the denominator becomes 1, and 1 by 1 is equals to 1. Similarly, when the value of x becomes is equals to minus infinity, then e to the power plus infinity will be something that we will have at the denominator, because the value of x is already minus infinity, and as per the formula, the exponential term on top of e should already be in minus. So minus and minus will be plus infinity, and this entire term at the denominator will become infinity, and this is why the final value will be close to 0. However, when the value of x will be 0, this term will become 1, and this entire term will become 0.5, and this is how, playing around with this value, we finally calculate the prediction for the logistic regression function. Again, I will give you a quick revision that the logistic regression does nothing but draws a straight line the way it is done for a linear regression model. Then it passes the value of the straight line, or the value of this y hat, to this sigmoid function, which squeezes the straight line in such a way that with the help of a threshold value, it can help us to decide that which class we should go with. If the predicted value is greater than the threshold value, we will go with the class 1, or if it is lesser than the threshold value, we will go with the other class around. Now let's understand that what are the basic assumptions before using a logistic regression algorithm. First point is that data should be linearly separable, which simply means that if you are working with two classes or more than two classes, they should not be overlapping with each other. In that case, the logistic regression is not likely to perform good, and for those such cases, we have other machine learning models like SVM or decision tree, etc. But definitely logistic regression would not be a good choice for overlapping classes. Second point is that the observations should be independent of each other. So there should not be any relation between our observation. There should not be any multicollinearity among the variables or the features that we have, which means, let's say, in order to predict a target variable, if we have three features, let's say feature 1, feature 2 and feature 3, then all these features should be independent of each other, which means it should not work like if feature 1 is increasing, then feature 2 is also increasing, because in such cases, this might lead to poor performance of the machine learning model. There should not be any extreme outliers, and it is really important to understand, because if you have outliers within your data set, in that case, let's say you have a class like this and you have another class like this, of course, the sigmoid function can help you to draw a line like this, which can help you to make decision between two classes. But let's say you have an extreme outlier over here at this point. At that time, your straight line or the sigmoid line will look something like this, and then you will end up misclassifying these points. So of course, we need to understand that this particular algorithm, logistic regression, does not work well in terms of extreme outliers. It is sensitive to outliers. There should be a linear relationship between the explanatory variables and the logit of the response variables. Now, logit of the response variable is nothing but a function that looks something like this, that log of p by 1 minus p, where p is nothing but the probability for a given class, and this entire term should have a linear relationship with our features, which is helping us to predict for the outcome. And finally, the sample size should be efficiently large enough in order to train the model. Now let's quickly have a look on the advantages of using this algorithm. Of course, it is easy to implement. This can be extended to multiple classes as well. So it isn't necessary that you only have to predict or classify between only two classes. There can be more than two classes as well, like 4 classes or 6 classes. In those cases, we can use the concept of multinomial regression, which works very similar to logistic regression, but it helps you to classify among more than two classes. Of course, this performs very well with linearly separable dataset, as we have discussed earlier, and the model allows to be updated relatively easier with new data. Now, what does this mean? Let's say within your training, the value of the parameters that your model is calculating. Parameters are nothing but the beta 0, beta 1, the values that we have seen earlier within the equation of a straight line. Those values can be updated easily when you are training with new data. Let's say in the future you are feeding some new data to your previously trained model, then the model allows itself to be updated relatively easier compared to other machine learning algorithm. Now let's quickly go through the disadvantages of using this particular algorithm. And the first one is high dimensional data may cause overfitting. Of course, if you are using too many features, in that case, the model will tend to overfit. We have already covered the topic of overfitting within the lecture of bias and variance. So in case if you have not watched that video yet, please consider watching it. In a nutshell, overfitting is nothing but the performance of the model being really good on the training data, but it fails to perform well on the testing data. Second point says, linearly separable data is rarely found in real world scenario. Of course, this is absolutely true. I mean, I can tell you one thing with guarantee, that I've been working within the field of ML and AI for more than past 3 to 4 years, and I have never seen anyone using logistic regression algorithm for a real world problem. But still, logistic regression is a topic that you cannot skip. Although it is not being used to solve real world problems, but still you will be asked questions on this topic in your interviews. So it is really important that you prepare this topic and you should have a really clear understanding on this particular algorithm. Scaling is required for better convergence, hence sometimes lots of feature engineering is needed. In case you are not familiar with scaling, then scaling is nothing but compressing the value of our features in such a way that they fall within the range of 0 to 1. And when you do this, it helps you for a better convergence, which means nothing but achieving the minimum loss for your machine learning model. So I believe that you found it helpful in order to have a clear understanding on the topic of logistic regression. If yes, please do consider dropping a like below. Share the link of this playlist with your friends or other people who may find it useful, and that will be a big support to us as well. And that will be really motivating for me as well in order to keep on bringing this kind of tutorial for you. So that was all for today. Thank you very much for your time.